Welcome to this Java Break with Basis. This is a continuing series on how version 11 improves your bottom line, and today we'll take up the topic of what IPv6 means to you. We introduced this topic at a recent technical conference and the audience was a little mystified, so we thought this would be a good one to bring into the world of our Java Breaks and get some information out to our community. On today's agenda, we'll talk about what IPv6 is. And in order to introduce that topic, we really have to touch on what IPv4 has been. Then we'll look at what the repercussions are of the transition to IPv6, asking if you are ready, and we'll do some demonstrations on different machines that will indicate the capability or readiness for IPv6. And we will digress briefly into some of the new naming conventions. And perhaps the best news is that Basis is ready for IPv6 within the interpreter of your choice from the Basis product line with no effort required of you at all. And since it's part of the how version 11 improves your bottom line, this is indeed a new revenue opportunity for you to explore with your customers sooner rather than later. And at the end, we'll take up your questions and address them with answers. In the course of today's session, I'll be joined by Amir Child, our training and sales specialist. So how did we get here? Where did all the addresses go? Back in the early 80s, with the design of IPv4, it provided for about 4.3 billion addresses, which were then distributed by the Internet Assigned Numbers Authority. The depletion of this pool has been a concern since the late 80s with the explosion of the Internet, and a task force was set up in the early 1990s. The estimates show that there will be 50 billion devices actively connected to the Internet by the year 2020. So where have all the IPv4 addresses been going? Well, mobile devices, for one. Mobile devices have become viable internet hosts, and they've been consuming a lot of those addresses. Additionally, new specs for 4G devices have pushed technologically the requirement for IPv6 addresses. Another source for address depletion has been always-on connections. Gone are the days of telephone modem dial-ups. Broadband connections are always active, and as gateway devices, routers, broadband modems, and others are rarely turned off, so the address uptake by the ISPs have continued on an accelerated pace. Also, the internet demographics. There are hundreds of millions of households in the developed world. Back in the 1990s, there was just a tiny fraction of those households that had internet connectivity. 15 years later, almost half of them had persistent broadband connections. And I put a note there that there has been an explosive growth in internet usage out of the Asian community, specifically India and China. There was also very inefficient allocation of the addresses themselves. The addresses to large companies and universities were actually assigned in address blocks of 16 million. And the reason that they had those blocks, such large blocks, is that the next step down from that, a Class B block, only had 65,000 addresses. So they're defaulted to over-allocating most large organizations early on. And the next is kind of a startling chart. So how fast is the depletion of IPv4 addresses? This charting will give you an idea. You see the available addresses on the axes to the left, and across the bottom is our year timeline. And you see the one that's really crashing, which is the APNIC area, which is the blue bar, and that is the Asia Pacific region. And the last block of IPv4 addresses have actually already been given out to providers and networkers. The purple line for ARIN represents United States, Canada, and the Caribbean. Africa is represented by the green line, and it has, as one would expect, a softer line of declining IPv4 address availability. So as these addresses have dried up, some interesting things have occurred. In fact, just this spring, Microsoft dropped $7.5 million on a batch of IPv4 addresses that were purchased in a bidding, actually, from a bankrupt company. And it's the first sale of IPv addresses, IPv4 or 6 addresses of its kind. Historically, they've always been given out free, of course, and it sheds some light on the increasing value of these old addresses in the short term as people are making the slow transition over to IPv6. The pool of internet addresses used for most traffic today is near exhaustion, but adopting IPv6, the new internet protocol with 4 billion times as many addresses, has been slow, despite the fact that the idea of IPv6 is more than a decade old. As one would also expect, the top companies, the largest global companies, have been ready and are positioned to move forward successfully into this transitional period. Comcast, for instance, began more than 5 years ago, and their entire communication network is either IPv6 enabled or IPv6 capable. Facebook has an IPv6 address. It's very happy about. If you take a look at what we have there in bold, Facebook has also been offering an IPv6 website for the last year. And Google has been preparing for several years, and its main search engine is currently accessible through the IPv6 address shown. So the big boys are ready, and the smaller organizations and mid-sized organizations are the ones that have been very slow to come up to speed on this transition that is coming. Back in June of this year was a World IPv6 Day, and the major players in the industry voluntarily decided to embark on this 24-hour test period. Some of those are AOL, Cisco, YouTube, Google, and Basis, and they enabled IPv6 on their primary websites. And the goal of the whole 24-hour day, the IPv6 Day, was to motivate other organizations to prepare their services for the transition to IPv6. Organizations that participated in the one-day test are continuing to perform testing and analyses, and one player, as I mentioned a moment ago, Facebook, has elected to leave their developer site fully IPv6 enabled.
Thanks, Paul. As we mentioned, IPv6 stands for Internet Protocol version 6. As with IPv4, you have an origin address and a destination address. However, IPv6 uses 128-bit addressing, whereas IPv4 utilized 32-bit addressing. What are the repercussions? Many internet users will likely find they can't use IPv6, since a new protocol needs to be enabled every step of the link, including the ISP and any intermediate routers, as well as your browser and any servers themselves. For this reason, all sites and carrier networks aim to be dual stacked. That means they support both versions of the protocol through this transition period. However, there are folks out there providing temporary tunneling products, but we won't go into them here. Most PCs and modern OSs are IPv6 ready. Networking devices will require IPv6 support. However, if you're utilizing internal routers, you may need to get software updates or firmware updates for those routers, or possibly replace those routers. Going forward, IPv4 will be supported less and less. While all hardware is already ready for IPv6, administrators will be stuck troubleshooting system problems that may ultimately be IPv6 default issues on a system that is not ready. So they will be learning IPv6 whether they want to or not. The first area to be affected by this transition to IPv6 will be outward-facing internet applications. Some of the naming conventions for IPv6 enabled sites would include ipv6.google.com or www.v6.facebook.com. Some convention examples would be ipv6.domainname.com or www6.domainname.com. Now let's take a look at PWE 04. So here we are at PWE. As you can see, pwe.lab.bt.es provides you with an IPv4 exhaustion counter. So this counter gives you a little bit of real-time information on the number of addresses and how quickly they are going. In preparation for IPv6 in the update to our product line, we converted our network systems to run IPv6. If you try to go to the Google or Facebook IPv6 links on the screen, they will probably fail unless you have updated your internal network. So here at Basis, you can see that we can go to ipv6.google.com as well as Facebook at www.v6.facebook.com. So as you can tell, it looks exactly the same, and when the rollout to IPv6 happens, that URL will ultimately just be www.facebook.com or www.google.com. Here we have a link to omgipv6.com. This is a link that'll show you if your site is IPv6 ready. So if you went to this link on an IPv6 network, you would see this message saying you are ready. Here, internally, as you can see, we have taken our websites and made them IPv6 accessible. Down in the lower left-hand corner of the screen of the add-on website, you see, "Are you ready for IPv6?" There is a button there. You can see it with a green checkbox. If you were to click that button, you would see this message. This is a validation screen that states that www.addonsoftware.com is IPv6 ready. Basis is ready for the eventuality of IPv6. You too can be IPv6 compliant and functional without any code changes to your application. You only need to upgrade to version 11 of your favorite Basis product. Here's a list of logos for BBX version 11 that tell you that we are IPv6 ready. We've modified our logos as they appear on basis.com with an IPv6 logo showing you they're ready. Next, we're going to go into some IPv6 connectivity demos. We're going to show you Visual Pro 5 to a Pro 5 data server, Visual Pro 5 in a BLM, Enterprise Manager, and BBJ. Let's get started. In this first demo, we are going to be pinging a machine called Patrick that is currently using an IPv6 address. Then secondly, we're going to show you a second address by pinging an additional machine on our IPv6 network. Here we are connected to patrick.basis.com. This is a machine running on our IPv6 network, and we're going to bring up command prompt. We're going to ping localhost. As you can see from the result, that when you ping localhost, you see we get returned a ::1, unlike what we used to see, which was 127.0.0.1. In this next example, we're going to go ahead and ping Bruno, another server on our IPv6 network. And you can see from the reply on the ping that we are going to the IPv6 address for that machine, 2001:4870, etc., etc. In this next demo, we're going to show Visual Pro 5 version 11.x connecting to a BLM, and we're going to successfully show you connecting Visual Pro 5 to a Pro 5 data server on an IPv6 network as well. In our next demonstration, we're going to run Visual Pro 5, and we are going to connect to an IPv6 data server and a BBJ P5 data server over IPv6. As you can see, we're running version 11.0. Here we are listing out the program, and you can see we are running to port 1100, and we're running to port 2100. As you can see, we connected to the Pro 5 data server. We were able to read a record over the IPv6 server, and we returned CH Chili products. In addition, you can see in the second description there that we connected to a BBJ Pro 5 data server over IPv6 and returned the CH Chili products as well. In this next demo, we're going to show a Visual Pro 5 Rev 10 failing to connect to an IPv6 BLM. In addition, we're also going to show you it failing connecting to an IPv6 data server. As you saw in the previous demo, if you were using Visual Pro 5 version 11 or Pro 5 version 11, this would work with no program changes or configuration changes. In this next demonstration, we're going to show you Visual Pro 5 10.01 trying to connect to an IPv6 BLM. As you can see, you get a nag message stating that it's unable to connect. In addition, you're unable to connect to the data server on Bruno again because that is a IPv6 data server running. So one of the nice benefits of going to version 11 is with no configuration changes and no program changes, you are able to connect to an IPv6 machine without issue. In this next demo, we will be using WebStart to connect from Patrick to Bruno over an IPv6 network. You will see us launching Enterprise Manager from the client machine and connecting to the server in the back room. In this next demo, we're going to go through the Enterprise Manager. Again, as you can see, we're connecting to Bruno, which is our fully IPv6 server. And with a click of a button, you can see that the Enterprise Manager, and we're going to bruno.basis.com. We're going to log in with admin. And there we are. bruno.basis.com running revision 11. In this next demo, we will be demoing LaunchDock, our menuing system via WebStart. It shows BBJ is fully IPv6 compatible. In this next demo, we're going to show you our LaunchDock that we brought out a few years back at TechCon. And again, our LaunchDock is running on our IPv6 server Bruno. As you can tell, comes up. Now we're going to go into language interpreter. we're going to kick off go into BBJ controls, and now we're going to kick off our font chooser application. And as you can see, font chooser kicks off, no problems. Again, all this is running on an IPv6 server. In our final demo, we're going to run a commercial off-the-shelf Java application called DB Visualizer. It will show how we are connecting to Basis database using the BBJ JDBC driver. Again, this is showing you how the JDBC driver is fully IPv6 compatible. In this next example, we're going to kick off a free Java application called BB Visualizer. In this demonstration, we're going to show you our BBJ JDBC driver connecting to an IPv6 server called Bruno. And as you can see from the database URL, you can see our IPv6 address is there, and we're going to connect to the Chili Company database. So we're now connected. We click on our database, and now we can see a list of tables that are in that database, all over IPv6.
This Java Break Summer Series has been titled How Version 11 Improves Your Bottom Line, and the IPv6 readiness of the Basics product line presents you with a new revenue opportunity. You can make the move into the new world of IPv6 without changing software. All you need to do is upgrade your customer to version 11 of your favorite Basis interpreter, and you're good to go. The conversations with your customers, though, need to begin right now. So in summary, we've covered a fair amount of material here in introducing what IPv6 is about. We actually went backwards a little bit and discussed what IPv4 has always been about. We talked about the repercussions of moving to IPv6 and some demonstrations basically to ask the question, are you ready for this transition? We looked at some of the naming conventions that are already out there, and the good news is, again, Basis is ready with no software change effort required on your part at all. And because Basis is ready with our version 11 products, we are delivering a revenue opportunity to you that you may not have had as part of your business strategy over the next year. So let's look ahead to see what's coming up. On August 3rd, we will be looking at new Barista enhancements, again with the idea there about improving your bottom line. Let's take a look at some of the things we'll be touching on. One of the features we'll present is the new one-button export function, which will allow your users to self-serve their queried data directly into an Excel spreadsheet. Here we are in a standard inquiry. First of all, of course, you can filter them, you can copy them, and print them, as you see in the first small window. You can now export them directly into PDF, CSV, TXT, XLS, and XLM document types. We've also added a new query definition. What it does is it provides for open-ended, multi-table inquiries. You can construct as complex an SQL statement as you like. You can nest SQL select statements. You can include store procedure calls to generate your inquiry. From there, you have the utilities to export that data through dockout to most any file format that you like. So power users can create their own reports, delivering significant productivity gains at the office level. It's very, very powerful new functionality, and we'll be discussing this on August 3rd. On August 17, we'll present our browser user interface and cascading style sheets, which are most applicable on mobile devices or any browser on your desktop. We'll show you how to enable your desktop apps for the web and how to use the built-in Jetty server to serve up those apps to the World Wide Web. The cascading style sheets element allows your BUI app to be customized in terms of look and feel while your BBJ code remains unchanged. Only the external CSS file has changed, and we'll be reviewing that with you on August 17th. Now let's take your questions.